Well, hello, everyone, and welcome to the January 2024 edition of the St. Louis Java Users Group. So for those of you who don't know, I'll see if I can advance my slide, which it is not advancing. There. The St. Louis Java Users Group has been meeting since May of 1997. Attendance is free. We don't maintain a formal membership list. And when we meet in person, which we're doing tonight, our normal meeting date is the second Thursday of every month except December when there is no meeting. There's just too many things going on over the holidays for us to organize a meeting in December. And if you're here in person, you can join us for food and social at 6 p.m. and the meeting starts at 6:30 p.m. And so for the in-person meeting that we're at right now, we're in the Object Computing Incorporated training room, and that's at 12,140 Woodcrest Executive Drive, Suite 310, and that's in St. Louis, Missouri. I'd like to introduce you to the other members of the St. Louis Java Users Group Steering Committee. So from left to right, we have Ted Doyle, Todd Zimmerman, Bruce Alspaugh, that's me in the middle, Wei-Chi Gao, and Kathy Zwang. You can reach all of us at the steering committee by sending an email to that address that's at the bottom of your screen. That's javasigsc@ociweb.com. And I'd also like to introduce everyone to our newest member of the St. Louis Java Users Group Steering Committee. He's right here in the room, Robert Levitt. The St. Louis Java Users Group would not be possible without the support of our JUG sponsors. So from left to right, top to bottom, we have Object Computing Incorporated. They have been with us since 1997. They are our lead sponsor, and I'd like to thank them again for sponsoring the training room tonight and the pizza that those of us who are here have been able to have, and as well as our speaker tonight, Zach Klein. JFrog has also been an important sponsor. They have covered the cost of the Zoom subscription, which allows us to send these meetings out so that it'll be free for you to watch online. And yes, this meeting will be recorded. We're recording it now. I know that question keeps coming up. I will post a link to it on the meetup group in the discussion for this meeting after the meeting. It probably won't be until sometime over the weekend when I can download all of the video and then get it uploaded to YouTube. But yes, all of our meetings are up on YouTube if you go to that channel through the pandemic. Now, we also will be raffling 2 JetBrains licenses tonight. And we will also be raffling at the end of this meeting 2 Manning ebooks. Now, if you're watching the recording, I'm sorry, you're too late. You do have to be present to win, either online or in person. So if you're joining us through Zoom, yes, you can participate in the raffle through the chat at the end of the meeting after the presentation. So there's some motivation for you there to stick around through the end of the meeting. And we could use additional sponsors. So if you're out there, we now have sponsorship opportunities for things like food, and you can contact us, particularly if you're trying to fill Java positions or something like that. Send us an email at the steering committee, and we'll see if we can get you on board as a sponsor. We do have sponsorship opportunities. Manning has been very nice. They've got a 40% off discount code if you use that when you place your order online, JUG 13. We've got a J Champions conference coming up. That is a free online conference that'll be running 8 a.m. to 4 p.m. Central Standard Time on those 4 days, the 25th, 26th, 29th, and 30th. And you can register for that if you go to that website there that's at the bottom of your screen, jchampionsconf.com. But that's not the only conference that's going on. Developer Week 2024 is making available free open passes. So they have an in-person version of Developer Week on the February 21st through 23rd in Oakland, California. But you can also catch it online February 27th through the 29th, live online. And if you want to know all of the details about that, go to that website, developerweek.com. Now, to get the free open pass, though, you should use the registration link that is posted on our meetup bulletin board. And I have a little announcement. So if you just go to our meetup group, that's meetup.com/gatewayjug, we have a bulletin board up there where I announce conferences like this, and there's a link that will get you registered for your free open pass. No Fluff, Just Stuff is coming up in St. Louis. That will be April 5th and 6th, 2024. That is available both online and in person in St. Louis. And we have a Jug discount code for that one as well. That's Jug 100 NFJS 24. You can get all the details there at nofluffjuststuff.com/St. Louis. And Jay Zimmerman, who runs that conference, has been very nice. And he will be sponsoring next month's speaker, who's one of his speakers who normally speaks at No Fluff, Just Stuff. And I'll get to that in just a moment. And of course, there's the largest Java developer conference in North America, and that's DevNexus 2024, April 9th through the 11th, and that will be in Atlanta, Georgia. And you can get the details there at devnexus.com. So I mentioned upcoming presentations next month on February 8th, 2024. We will have Architectural Principles, Building the Foundations of Design Excellence by Ken Sipe of Edward Jones. I believe he's a St. Louis native here, and he's also part of the No Fluff Just Stuff speaking tour to talk about software architecture. So I've been looking forward to that one. So Jay at No Fluff Just Stuff has offered to have him come in, and then they will sponsor the food for February. They said they cover the cost. So if you want to keep up with our presentations at the Java Users Group, just go to our meetup site, meetup.com/gatewayjug. And as presentations are scheduled, they're posted on our meetup group. And you'll get the latest on our schedule and location. And you can actually go ahead and RSVP for next month's meeting because it is up there. Now, if you're interested in giving a presentation or sponsoring the Jug, you can just send an email to the steering committee at that same email address before. That's javasigsc@ociweb.com. So enough of me talking. Let's see if we can get to tonight's presentation on event-driven microservices with Apache Kafka and Micronaut. So I'm going to hand over the computer over to Zach Klein at OCI. Thank you.
All right, is this working? Testing 1, 2, 3. There we go. All right. All right, well, thank you, Bruce. Thank you to everyone who's joined us online. Let me just get a couple of things switched over here. That one. All right. So, welcome again. My name is Zachary Klein, and I was already introduced, so thank you, Bruce. We'll be talking about event-driven microservices with Apache Kafka and Micronaut. So this is effectively 3 talks wrapped into one. And it's actually a subset of material from a training course that I've developed and delivered for OCI. But I think we'll be able to get through all the content here this evening. So as has already been said, I work here at OCI as a developer and an architect. As a principal software engineer, I also lead the 2GM team, and I've been doing this Java software thing for about 14 years. Where is that noise coming from? I think must not have this quite positioned right. There we go. All right, and enough about me. Let's look at our agenda. So just to kind of get a poll of the room here, and sorry for folks online, I can't see you very well, but for folks here in the room, who here is familiar with event-driven architecture? Okay, a few hands. How about Apache Kafka in particular? All right, and lastly, who is familiar with the Micronaut framework? Okay, good. So I saw a few different combinations of hands going up. So I'm pretty sure there'll be something new for you, no matter what you did with your hands just there. But at the end of the presentation, we're going to kind of bring all of these 3 topics together as we talk about how to actually build and implement event-driven microservices using the Micronaut framework. But even if you're not using Micronaut, you're still going to get something out of this presentation. So let's get right into this. There we go. All right, so what do we mean by event-driven architecture? So we go back in time a little bit. We used to build an application, right? A Java application. Of course, I am speaking here mostly in terms of web services. We build a back-end application. Maybe it's a CRUD application. Maybe we have a database and we're doing some persistence. And we want to make this available, usually, let's just say for simplicity, over the World Wide Web. And so we've got our users and they make requests against our application. And our application does its little thing and it returns a response. So those were the good old days when things were simple. You just run your application, you drop your jar file into Tomcat, right? And if you need more resources, you just increase the RAM. It's not a big deal. Just change your Java args, add a few more sticks to the server, and you're all good to go. And then over time, this sort of thing started to happen. And we started to run into this problem where we had applications that were growing in size, growing in complexity. And the big issue comes down to these applications, you can scale them in a sense. You could always shovel more RAM into the server, but that's not really reflective of the actual demands on the application, because your entire application in most cases is not actually suffering under that intense load. Usually it's only a few components of your application, a few features, a few endpoints that are getting most of this traffic. And so this is not an effective way to scale and have applications that are robust. You also have, of course, a single point of failure. If the application goes down, your whole site's down, right? And so you don't have a very good resilience in cases where a particular portion of the application is suffering under higher than expected load. And so microservices were supposed to be a way to kind of alleviate some of these problems, okay? So with microservices, we're going to break apart this big old, we now call monolithic application into discrete services, smaller applications typically, although size is kind of irrelevant to the term. Microservices can be as big as you want them to be, but the vision of a microservice is that it's focused on a particular task. And then rather than having to scale your entire application up, you can scale the individual services that are needed, that need to handle extra load. You can run multiple instances of a given service. And so you can end up with better usage of resources, and you can have a more resilient system, theoretically, because you can have the rest of your services might be able to do some work, even if one of their sibling services might be out of commission for whatever reason. And so there's a number of advantages that microservices bring to the web services space, along with some added complexity, right? Because now you're building a distributed system, and now you've got multiple points of failure, potentially. And so it brings with it opportunity, but also it brings with it a set of challenges. Now, the real feature, and if you read, I've linked to a couple of Martin Fowler's articles because I found them really helpful as I was preparing this. The thing that really sets microservices apart, and sometimes I think is missed when we talk about them, is this concept of a bounded context. Are folks here familiar with that term, bounded context? I'm seeing some nods, and so I'm seeing some head shakes too. All right, so a bounded context, the idea here is not just that we've broken up our big chunk of code into smaller chunks of code. That actually doesn't do very much for us. In fact, it actually makes our job harder. What microservices are supposed to do is they're supposed to represent an independent combination of functionality and data that can be developed and can grow and evolve independently from the others. All right, that's the idea of a bounded context. This gateway service here, it's got a little database, maybe that's a cache of some sort. It owns that data, okay? It doesn't share it with inventory, it doesn't share it with vendor, and so on and so forth. Each of these services has domain control over the data that pertains to what it does. And so an ideal microservice, if you're building kind of a textbook implementation, each service is going to have a particular job, a particular set of functionality, but it's also going to have control over its data. And that's really what brings microservices into their own. If you're just splitting up your code, all you're doing is introducing latency and complexity. But if you have a bounded context and you have the ability for one team to be working on this vendor service, another team working on inventory, and they can use their preferred technology, they can use their preferred frameworks and tools and so forth, And they just have to have some sort of contract that controls how they communicate amongst themselves. That's where microservices can do a lot for you. But there are still challenges here, of course. There's always challenges. One challenge is that it is a distributed system. And so these services, a lot of early microservice architectures, and even still today, a lot of them communicate over HTTP. That's not an ideal inter-service communication mechanism. There's a lot of, you bring in latency, you bring in the possibility of network requests failing and so forth. So you've got inter-service communication. That's one challenge. Another challenge, at risk of getting a little bit computer sciencey, Martin Fowler again has a really good article on this called Conway's Law. And the gist of this idea is that the way that an organization communicates internally, the people that talk to each other, the people that work together, whatever that structure is in an organization, the software they write begins to mimic that organization. The people who talk to each other will write software that works together, and they'll do so independently from the folks that are maybe separated either geographically or separated within the organization. And so, like it or not, you don't end up building these bounded contexts in the way that makes the most sense academically. It tends to reflect more of the human component going on in the development of the system. And really what we're getting at here is this idea of a data silo. Okay, so a bounded context sounds great, but the other term for that is a data silo, and that doesn't sound so good. The challenge with the data silo, of course, so a bounded context gives us data ownership, and that's really important. If you don't have that, then you can't really effectively deploy microservices or develop microservices. It allows each application to evolve and optimize without breaking the entire system. That's the goal. But in the real world, the boundaries of our services don't actually reflect the real world data needs of the business. And the issue comes down to services need data that doesn't actually belong to them. We always end up with these situations where a service needs to know something that isn't really its job. And so what do? Well, the service talks to another service who does own that data. Well, now all of a sudden we have a service that to do its job effectively needs to communicate with a bunch of other services. And now the complexity of our microservice architecture begins to explode. And so there's multiple ways to deal with this problem. One answer might be maybe this should be a microservice. So if you've got a single service that can't do its job without communicating to 2 or 3 other services, you may have been a little bit too granular in how you broke apart your application. The other way that, of course, we try to fix this problem is by sharing data stores, right? Sharing a database. And there's problems with that, especially if you are trying to build a microservice architecture and you are interested in horizontal scalability and you're interested in good failover behavior and so forth. If everyone's tied to a central data store, that's intuitively, that seems to be a problem, okay? Databases really don't work well for this kind of situation because we have to deal with data consistency, we have to deal with synchronous processing, transactions, and so forth. We have to deal with database locking, and it becomes a real headache. So the problem we're facing is that microservices work great academically, and they can handle some problems really well, but once the real world business needs of the application start breaking that bounded context, those benefits start to go away. So introducing event-driven architecture. So event-driven architecture, before I talk about how it solves the problem, I'm going to try to define it because there's a number of terms that can get conflated here. Event-driven architecture combines elements of microservices, message queues, pub/sub, publish and subscribe, and service-oriented architectures. And if you don't know what those words mean, that's fine. But if you do, just know that there is a connection here. And the key thing with event-driven architecture is that events are used to represent the state or the data of the system, as well as the communication amongst different components or services in this case. So this is different, I'm going to talk about this later, than simply messaging or even eventing. Because at one level, every system is eventing. It's doing things and letting other components know what happened. But that's not, strictly speaking, event-driven architecture. Event-driven architecture uses events to represent the data itself as well as the things going on in the system. We'll break that down a little bit here in a minute. So each service or each component, however, whatever you want to put there in that word, but each actor in the system will receive events or consume events that pertain to its job, its bounded context, and then produce events as an output. So let's break this down maybe a little more simply. There's kind of 4 elements that describe event-driven architecture, and the last 2 are related, and I'll talk about them together. So the first is the event itself. Something happened. An order was placed. A shipment was received. A transaction was settled. A sale was voided for some reason, right? Something happens. That's event notification. The second, though, is state transfer, actually propagating data through the system. This is really where, with event notification, if I just went back to that first one alone, all sorts of things fit into that category, right? And there's a lot of eventing systems like messaging that rely on event notification of asynchronously letting different components of the system know what's going on. But once you receive that notification, you have to go do a query or you have to go retrieve the data in some other way. It's just letting you know something happened. And that's not, strictly speaking, event-driven architecture. Event-driven architecture is where you have state that's being transferred between components of the system through these events. And then the third element is called event sourcing, and this builds on the previous 2. With event sourcing, the core data model of the system is actually an event stream. And an analogy that someone just mentioned to me recently, and it was really helpful in explaining this, is version control, right? If you ever go to a Git repository, you can browse the code and you can see all the artifacts and everything that's in that repository. But if that's all it was, that would just be file sharing, right? That would not be version control. What makes Git so powerful is that for every single file, every single element in that repository, you have a full record of the events that went in to produce the final state that you're looking at, which means you can go back in time and reconstitute that repository at any point in its past, all the way back to that initial commit and the initial git ignore file or whatever it is that they checked in when they first created the repo. So that is what we mean by event sourcing. The actual source of truth is a stream of events. Now, that does not mean, I'll talk about this in a moment, that does not mean that you're gonna throw away your database. That does not mean that you're not gonna use other mechanisms to store and query and analyze data. But it means that the system of record is a stream of sequential events. And these events are typically going to be immutable. You can't go back and change what happened, but you can do something new, right? And you can, and that there's a lot of benefits that you can probably already see that come out of this. The last element there is CQRS, command query responsibility segregation. I'm not going to go into a lot of detail there. If we want to talk about it during the Q&A or whatever, that's fine. It really builds off event sourcing, and it just addresses the fact that in real world systems, an event stream is powerful, right? But you do need to browse the repo at some point. You need a way to actually query and get back a given set of state. And so CQRS kind of bridges that gap between an event streaming model and more of a query and read model that is a little more conventional. And so typically, if you use number 3, you'll also use number 4. But technically speaking, you can do event-driven architecture with just number 1 and 2. Event sourcing is where you're really ready to say event stream is going to be my source of truth. But you can still make use of event-driven architecture and not technically do event sourcing. We could talk about that. It's kind of a design decision. Okay, so let's define an event. And by the way, I'm talking about event-driven architecture generically right now, although the language I use is going to be essentially Kafka language. But it's not, the concepts are not Kafka unique necessarily. But since we're going to talk about Kafka, I will use that kind of vocabulary. So an event represents a notification and some piece of state. So notification in this case, an order was placed. Past tense, the order has been placed. It's something that's occurred in the system. And then along with that is the state, the data that represents that order. These events then are placed on topics. A topic is, I refer to as a persistent queue, but that word persistent is very important. If you just say queue, people will get the wrong idea. They're persistent, meaning that once the event goes on the queue, it doesn't go away when somebody reads it. Okay, it's a piece of data and it's going to stay there, just like the Git commits in your repository. Every event in the topic has an offset. So there'll be a unique index for that event on that given topic. And then the events can be read from the topic through multiple modes. They can be read from the very end, just getting the latest event and then moving forward from there. You can ingest all the events starting at the very beginning of the topic. They can be read in as batches, and they can be queried through various means. When a new event comes into the system, it's going to be given some sort of a key, typically, although technically that's optional, but generally speaking, your events will have a key, and they're going to be placed on the topic at the next index marker. And topics can be partitioned. And I'm not going to go into a lot of detail here, but what I want to point out here is that when you have partitioned topics, and this is a Kafka thing now, Kafka will guarantee that any event that has the same key will end up on the same partition of a topic. And that's a subtle feature, but it's actually very powerful, especially in more advanced usages of Kafka, because it means that you can make certain assumptions about the event stream that's in a particular partition. So in this case, we've got a new event that's just come into our broker. Its key is B3. It's going to end up on that second partition. We got another event. Its key is C1. We've got C1 down here on our third partition to offset 1. So it's going to go down and end up on that third partition. So partitions give you a way of segmenting the data in the topic. This is not multi-tenancy or anything like that, but it does mean that you can, for example, this key could be a user ID, right? Or an order ID. And it gives you a way of kind of knowing, okay, all the events that pertain to a particular key are going to end up in one partition, and there's certain assumptions that you can make based on that. A couple more terms, producers and consumers. Producer is a application, a service, a bit of code that writes events to a topic. And a consumer is just the other way around. It reads events from topics. The events are typically read sequentially. As I said previously, there are ways to query events out of order, but the most common and the default mode is simply to read events as they come in, either from the beginning or from the latest, or from an arbitrary point. You can seek a particular offset and start from there and read forward from that point on. So we were talking about microservices earlier. Now we're talking about event-driven architecture. What happens when we put these two together? So now we can talk about the idea of event-driven microservice architecture. So we've got a set of microservices again. They've got their own bounded context. They've got their own control over their data. They can have a database. They can have a cache. They can store their data any way they want. But their communication and the way that the data is transferred between components in the system, between services, is now happening on these topics. And again, we're talking about Kafka here, so it's a Kafka cluster we're looking at. And so, and this is, obviously a contrived example, but there are a few things that we can illustrate here. We've got requests coming into a gateway, which is a producer, right? The gateway is going to produce events that take place in response to user interaction. The user makes a request, and so we're going to produce an event that goes onto a topic that represents that the user just placed an order, for example, right? And so we're going to put that into our order placed topic. And that's being read in by a couple of different microservices. We've got an inventory service, which is consuming off this topic. That makes sense. We probably need to check and make sure we've got the stuff they ordered, right? But we've also got a second consumer down here in orange, this vendor consumer. I don't know what he does, but maybe he's doing some sort of, I don't know, fraud detection service, right? Making sure that we're not getting duplicate orders in the system or something like that. So we got some service here that's managing some vendor or what have you, and it's consuming off the same topic. And that's fine. This might look a little bit odd if you're thinking in terms of message queues or something like that, but the events that are placed in that topic, they're just items of data that have taken place in a sequence, and there's no problem with multiple services consuming off that topic. Once the inventory has done its work and made sure that we have the products, it's going to produce an event of its own, and it's going to put that event on our product allocation topic. And that's going to be consumed by our delivery service to set up the shipment information and make sure we've got the customer's address and so forth. And that's going to publish, it's going to produce an event going onto the shipment created topic, and that gets picked up by our shipping service. And then down here, you've got an accounting service that's also pulling off of product allocation. And what I want to notice here is that there's not any central agent that's deciding who gets called when, right? With event-driven architecture, you want to prefer what we call choreography, where each service knows what it does in response to certain events, and then it lets the system know by producing new events what happened, as opposed to orchestration, where we've got some super smart brain in the system that is sort of determining what happens in a given order. Now that's a sliding scale, right? Because in the real world, systems will probably have some degree of orchestration versus some degree of independent services that are choreographed by means of how they consume and produce events to our event stream. This is more or less representing an event sourcing application, is what I'm trying to illustrate here, where the real source of truth is the topics. They are not simply there to let people know things happen. They actually are the event store. But again, that doesn't mean that individual services might not want to store that data in a database because it's easier to query, and databases are great. We've used them for a long time. So this is sort of an idealized event-driven approach. All right, so a few takeaways from event-driven microservices. Event-driven architecture plays to microservices' strengths, and that really is this idea of a bounded context. There are a few things that you have to kind of get over to do this. For one thing, and I think I mentioned this later on, data duplication, it happens in event-driven architecture. You will prefer to send entire objects, entire customer profiles or whatever, as opposed to just sending little bits of data. And that's a little bit counterintuitive sometimes, because it seems like unnecessary duplication intuitively sometimes. But in reality, if you're thinking of this this being your system of record, these events being the source of truth, there's nothing wrong with having that information in whole on a given topic. And you can always reconstitute, by looking at the latest event on a topic, and this is the customer's latest profile, for example. It makes more sense to do that versus saying, oh, they changed the first name. Here's one field. That requires extra querying. So event-driven architecture, if done correctly, plays to microservices' strengths. It allows individual services to own their own data, to have their own data stored, to have their own way of seeing the world, while also being able to benefit from all the data that's being published by other components in the system, just by consuming from those topics. Event-driven microservices are great for building loosely coupled services, if done correctly, just like any other architecture pattern. Microservices themselves work best when they are loosely coupled. But in the way that we traditionally do them, that's a difficult benefit to realize in the real world. With event-driven architecture, we have more opportunity for loose coupling. Multiple services can consume events from the same topic or topics. So these are not simply communication lines. It's not that I've got a topic coming from me to you. I've got a topic going just to Kafka, right? Going to my cluster. And anybody interested in that should be able to listen in, consume those events, and do useful work based on that. And this is really important. The events are persistable, and that means they're also replayable. I heard one speaker say that a system is truly event-driven or event-sourced if you can blow away everything in your database, blow away everything but your Kafka cluster, everything but your event stream, and you can rebuild your world simply from your event stream. If you can do that, then you've got a truly event-driven architecture. And obviously, that's very idealized, and there are real-world constraints that can make that a complicated problem. But that is more of the ideal that you're looking at when you're building with event-driven. Events can be materialized as in other forms, like tables. And there are tools for doing that come from the Kafka space, like KSQLDB. You can also do it by simply using a database, though, right? By reading in events and publish them to a table, and voila, you have created a table view of your topic. So you don't need to pick one or the other. These are both powerful models for dealing with data. And then as a benefit for event-driven microservices, the events implicitly replace REST calls or other means of inter-service communication, right? Instead of my services calling each other, they learn what they need to know about the world through these event streams, through what's happening on these topics. And so there's no need for the inventory service to know about the order service or shipping service. That's irrelevant. The inventory service does inventory. It knows what it needs to do. It knows what sorts of events it responds to, and it produces events itself to indicate that it's done its job. Now, if you're really interested in this topic, I highly recommend you check out this book, Building Event-Driven Microservices by Adam Bellamar. He goes into a lot of really cool topics like communication structure, event modeling, which is really, really important. And I think I might get into it later on, but not in detail. Scalability, scheduling, and this last one's really interesting. How do you integrate this with the traditional request response that we are so used to and that we often need, right, when it comes to exposing our services to the outside world? Because at some point, we are still using the request response model in most cases. We're building an API, and we're going to have API clients that are calling the API and blocking and waiting for us to give an answer. And there are ways around this. We could do things like returning some sort of a request ID, and then they come and query for the response later. But that might not be the right solution. And so he talks in detail about how do you kind of handle that, that transition between pure event-driven services that are all independent and they're reacting to events, and then the fact that we have a client waiting for an answer, right? How do we map that? And CQRS, which I mentioned earlier, that's a big part of that story. So I highly recommend checking out this book. So as we wrap up this section, a few distinctives. In event-driven architecture, the events are the source of truth. They're not just a way of saying, hey, this happened. They actually represent the data. Event modeling, this refers to the fact that we need to, just like if we do domain-driven design, we have to design how we represent our data in the system. When we use event-driven architecture, we have to take that a step farther. We have to model the events themselves. And that sometimes means looking at our system from a different perspective than we're used to and thinking about, well, what does represent an event in this case? An event is not, strictly speaking, a command. It's not an invocation. It's something took place, and then there's data associated with that. So event modeling is very important. That brings up things like event schemas, because we need to have a way of knowing what kind of events our services can expect and what they should be producing. And there are a number of tools that can help with that. This is a really important one that I like to bring up. That's the single writer principle. And this is a, take it or leave it. It's kind of an opinion, but I think it's got a lot going for it. And that is that only one service should be the producer, should be the writer to a particular topic. This is not a requirement of Kafka. It's not a technical requirement. What it means, though, is that I can look at a topic and know who is producing there, who's responsible for these events. It just makes an otherwise complicated event-driven system a little bit more discoverable than if I have a topic and I've got to go track down everybody who's writing to it. So it's a good thing to consider. Event-driven, I said this before, does not mean no database. Event-driven, in fact, loves databases. They are good things. We should use them. Even if we are doing event sourcing and the events represent the final source of truth, there's nothing wrong with pouring that data into a database for querying or sourcing that data from a database using something like change data capture, where we basically convert the inserts and updates in the database into events and then let that feed from our database into our event stream, into our Kafka cluster, for example. So there's no problem at all using databases in event-driven architecture. It's highly encouraged. All right. So now we're going to talk a little bit about Kafka. I've already introduced a lot of Kafka-isms in the discussion about event-driven, but we'll look at a few more specific things about Kafka itself. Apache Kafka is by far the dominant event streaming framework that's used in the industry today, especially in the Java space, but it's really a polyglot solution. Kafka was originally developed at LinkedIn, of all places. That was where the project got its start. Released in 2011. Its core is written in Scala and in Java, but there are client libraries available in pretty much all the major languages. And setting up Kafka, I'm going to show a simple example of how you can stand up a local instance with Docker. But this is typically going to be a cloud job, right? How you actually run your Kafka cluster. And it's going to be typically multiple instances of the Kafka broker, which is what handles the producers and consumers. A Kafka cluster can support any number of client applications, and it's been released under the Apache 2 license. So the term that folks like to use to describe Kafka is that it's an event streaming platform. So the idea here is that Kafka has one job, and that job is to manage streams of events. And how those events are written and read, and making sure that can be done in a highly scalable way. I'm going to skip through some of these things here because I've kind of already talked about them. Events are immutable. They're written to a log. Once they're written, you can't change them. That's a good thing. That means you can make certain assumptions about those events. They're persistent. They can be persistent indefinitely, or they can be persisted for a given length of time. That's something you can configure when you create your topics. The topics are partitioned. We talked about partitioning already, and they're optionally keyed. And as I showed earlier, the reason why you want to key your events, or a reason, is to have some control over the partitioning and where events are stored. So an event in Kafka is a byte array. It has a key that is nullable, as I mentioned previously. It has a value, which is just the data of the event. It can be in any format you like. It can be binary. It can be JSON. It can be something like Avro or some other schema management tool. And then optionally, it can have a timestamp and some number of headers. So the headers could be metadata that you might want to store about your events. Using Kafka, okay, I'll skip down to the middle there. Applications connect to Kafka through the consumer or producer APIs. So the library you're using will kind of determine how you do this, right? But at its core, you've got a consumer and a producer API, and you've got a bunch of configuration that can go into how those guys work. But that's really it. It's actually a pretty simple framework to integrate with. There's also this thing called Kafka Connect, which is really powerful and very cool, but I can't talk about it a lot here just for sake of time. But briefly, Kafka Connect is a framework that allows you to do things like what I mentioned previously with a database. If you want to, let's say, input a database into Kafka with change data capture, you can pull up a Kafka Connect library for your database, and you can make that a source and feed data from that database into a given topic. So Kafka Connect is this sort of framework that lets you integrate with a whole variety of potential data stores and then data syncs. Actually, I've got a diagram here that will show this in a minute. And then applications, the final point there, that require more advanced processing can make use of this library API called Kafka Streams. And we'll talk about that maybe in the Q&A if folks have questions about it. But we're going to move on. So this is a simple, very simple topology of a system using Kafka. We've got a Kafka cluster there in the center. We've got applications that are producers at the top, applications that are consumers at the bottom. An application can be both. That's not a problem, but for representation here. And then connectors, that's Kafka Connect. All right, so in this case, we've got a couple of databases. Maybe it's a legacy system, or maybe we're using a database for part of our architecture, and we want to be using that. So we've got one connector here that's pouring data from the database, feeding it into Kafka, pushing that data into Kafka. And then we've got a database that's reading from a Kafka topic. And these are both using the Kafka Connect API. So this is a great way to get data from a topic into a database and vice versa. And then stream processors there on the other side, that's Kafka Streams. And again, we won't have time to talk about that tonight, but we can maybe talk about it during the Q&A. Now, again, as I said earlier, setting up Kafka is typically a job for your cloud guys. But if you do want to use Kafka locally, just for demo purposes or experimentation, there's a few ways you can do it. But the easiest way for me is Docker. The link there at the bottom gives you some information on how to use Docker Compose and Confluent Platform, which is their community. They have a community version that you can use, and you can download Kafka and Zookeeper, which are the two services you require. You run this thing with Docker Compose up, and you've got Kafka running. And now you can use that with your services, and you're off to the races. This is, of course, not how you want to deploy Kafka in the real world, but it is a handy way to play around with it locally. All right. So now switching gears, we're going to talk about Micronaut. Introducing the Micronaut framework. So the Micronaut framework was actually built right here at OCI, and it is a JVM framework for building microservices. All right, and the development of Micronaut is now under the auspices of the Micronaut Foundation, which includes representatives from JetBrains, Microsoft, ThoughtWorks, Amazon, OCI, the company right here, as well as Oracle, which is not listed in this slide, but they're a very big part of this right now. In fact, they employ a number of full-time engineers that help develop the framework. And it's being used by a lot of big companies. This slide is out of date. I could easily add several more logos there. But it's being used by a number of large-scale organizations for building specifically cloud-native microservices. All right, so we're going to briefly introduce the framework here. Micronaut was designed, as the name suggests, with microservices in mind. Its key distinctives are very fast startup time and low memory footprint, very small executable jar files. Of course, that's dependent on the other libraries that you might want to include with your application, but on its own, it's very low, very resource efficient. And it does this through ahead of time compilation. And so what this means is that Micronaut does a lot of the framework work for you, the stuff that Spring and other Java frameworks will typically do. It does a lot of that for you at compilation time instead of at runtime. And that's really important when it comes to Java-based microservices. Java has a bit of a reputation, fairly or not, for being a bit bloated when it comes to runtime performance and building microservices or especially serverless applications. Micronaut solves that problem, at least in part, by doing the framework magic of sort of transforming your code and adding whatever functionality, proxies, caching, whatever it is that you're doing. It does as much of that at compilation time as possible so that the raw bytecode that you actually ship is much more efficient and actually has much less Micronaut in it at runtime. So Micronaut is a framework for building microservices and serverless apps. It is a generic Java framework, though. So any Java application that you want dependency injection and you want configuration and environment detection, if you want kind of advanced framework features in Java, you can use Micronaut, even if you're not building a web service. We already talked about ahead of time compilation. It provides dependency injection, AOP, code introspection. Those are all just kind of technical terms for the things that most modern Java frameworks typically do. Again, Micronaut does all this for you without using runtime reflection and without doing a lot of runtime inspecting or introspecting of your code. And then let me explain what I mean by that. So typically when a Java application starts up, right, and if you're using a traditional framework, let's say Spring, which I use Spring. Spring's a fantastic framework. There is a lot of magic that has to happen to actually make your Spring controller act like a controller, because you didn't write the controller, really. You wrote a pretty minimal set of code that expects there to be HTTP handling, expects there to be handling of a HTTP body and cookies and whatever else you're doing, right? That's all framework stuff. And typically in Java frameworks, that the work of actually adding those features and sort of souping up your code, that has happened at runtime. And that means that the framework has to inspect your code. It's got to look at all the methods, all the arguments, build up a cache so it knows what it is that this controller wants to do. And then that's how it manages to inject the framework behavior so that you don't have to write all that boring HTTP handling code. So Micronaut does the same thing, but it did that for you when you compiled your application. And so what you actually ship out and what you deploy are class files that have all of that functionality baked into them. And so Micronaut doesn't even really need to be part of the picture anymore when you're running the application when it comes to those particular features. So that's really the idea of avoiding reflection and avoiding runtime processing. Micronaut is a natively reactive framework. It's built on Netty. And we will just kind of jump through these things here. And the catchphrase that we like to use is that Micronaut is natively cloud native. So when we talk about microservices, we're usually talking about applications that we're not running on physical servers in our warehouse somewhere. We're typically talking about applications that run on a cloud platform that is dynamically allocating resources and so forth. And Micronaut was built with that type of deployment environment in mind. And so that means microservice has native support for things like service discovery, or distributed configuration, for client-side load balancing so that services can automatically share load between each other. And it natively supports serverless computing as well. So AWS Lambda, Azure, and so forth, Google Cloud Function, Cloud Run, and so forth. Distributed tracing, token propagation. And if those words don't mean anything to you, that's fine. But if you work in cloud native, you've heard these words, and they are problems that you deal with all the time. And they're not problems that were dealt with by a lot of Java frameworks when they were being designed and developed, even a decade ago. And so that is really one of Micronaut's great strengths, is that it was built with distributed systems in mind. And that is going to include, as we'll see, event-driven architecture. The easiest way to get started with Micronaut is to go to launch.micronaut.io. And there is, of course, dark mode. If you use IntelliJ IDEA, the Ultimate Edition, so if you win a license tonight, there's actually a Micronaut project wizard built into IntelliJ, which is pretty cool. And just to look at a couple of code examples so you kind of know what to expect when you start playing with Micronaut. This is an example of a simple controller. I think you should be able to read that and see what it does really easily, right? It exposes a get endpoint. It takes in a argument that's based on the path of the request there, that name parameter, and then it's going to print out a hello message. So an obligatory hello world. Very simple controller. And now what I want to show you is a client that interacts with this controller. So this is a Micronaut controller. Here is a Micronaut client, HTTP client, that interacts with that controller. And I'm showing this for a particular reason. What you see here, what you should notice, is that there's a lot of continuity between the server-side API for Micronaut and the client API, right? I mean, there's a couple annotations that are different. And with the client, we don't have to have any method body because Micronaut generates that for us based on our method signature. Micronaut can see, okay, we're going to make a GET request against this path, and this URL component name is going to be bound to a particular argument, and Micronaut can compile all of that HTTP handling for you when you compile your application. And what's cool here, what I find cool, is just that there's a really nice continuity between how you write the controller, how you write the client, and we're going to see that carries over when we start looking at Kafka and how Micronaut integrates with Apache Kafka. And that's what we're going to talk about now. So our last section, building event-driven microservices with Micronaut Kafka. So we have Micronaut, the framework for building cloud-native microservices without reflection that are really performant and really low memory consumption. And now we have Micronaut Kafka, which is an integration library between Micronaut and Kafka. And you can use the standard Java Kafka library with Micronaut. It's a Java framework. So if you've got any library that works with a Java with a Java application, you can use that with Micronaut. But it's probably going to bring in some runtime dependencies, some runtime processing. It's going to kind of count against some of the benefits that Micronaut was giving you, right? So Micronaut Kafka helps you have the best of both worlds. So Micronaut Kafka gives you access to the producer and consumer APIs from the Kafka library, but it does so through the same sort of declarative API that we just saw with our HTTP client, and it does so with reflection-free serialization and deserialization of events. So what that means is that when we transmit data, transfer data from like our object-oriented JVM world into something that's going to be pushed out to our Kafka topics, Micronaut does that serialization and deserialization without using reflection. So it will introspect our events, and it will generate the necessary code to do that serialization without having to do a lot of runtime work. And you can create applications that integrate with Apache Kafka that don't even include HTTP at all. And this is actually really cool because you can have services that they wake up and they connect to a Kafka cluster, and that is their connection to the real world. And so we can, typically we think of microservices, we think of something that has an HTTP layer. But strictly speaking, in an event-driven architecture, that's not necessarily the case. You might want an HTTP layer. You might want to have, some sort of metric endpoint or management endpoints on your service that you want to access internally. But you also might want to have an application that it just plugs into Kafka and it produces and consumes events, and you're off to the races. So to get started with Micronaut Kafka, you can create an app from the Micronaut launch website we just saw. And by the way, I jumped through that too fast. Let me point that out real quickly. So if we look at that slide again, so if you go to Micronaut launch, if you look at that upper left-hand option there where it says Micronaut application, that's a drop-down. If you open that up, you'll see there's an option for building what's called a messaging app. And if you choose that option, it's going to create a service that does not include HTTP. And so once you've done that, you can go down to this features button. And if you open that up, there's a whole set of, better idea. This is better shown than talked through. So let me see if I got my screen share switched over. I think I do. So we're just going to go to the website because this is more fun. So we're going to go launch.micronaut.io. Anyone else here using the Arc browser? Anyone else seen that? Okay. I've been playing around with it. It's interesting. I'm not entirely sure what all the fuss is about. All right. But it launches fast. So if I go here to Micronaut application, I can see that I can choose to build a number of different types of application. I can build a command line app, a function app, functional application, which would be like a Cloud Run or serverless application, or a messaging-driven application, okay? And so this just sets up some defaults that kind of make sense for a particular application type. I can choose my version of Java, 17 or 21, and if I go down here to features, there's a whole slew of things that I can add to my application. I can add support for Hibernate. I can add support for Micronaut data. I can add support for Liquibase and Mongo and Oracle and all sorts of cool stuff. If I type in Kafka here, I see I've got a couple options. I have Kafka and Kafka Streams. I'm going to choose Kafka here just for simplicity. And if I click on this preview button here, this is one of my favorite features because I can now open up the application that is going to be generated, and I can actually browse and see what it is that the framework is going to give me. And there won't be any code really here. Just got a simple application class with a main method. Nothing surprising there. If I go to my build.gradle, and it looks like we're defaulting to the Kotlin Gradle DSL now, but that's configurable. And I've got my Micronaut Kafka dependency set up here. So this is just an example of what you can do with the Micronaut launch website. It's really powerful. And once I'm happy with my application, I've chosen, okay, I want to use regular Gradle, not Gradle Kotlin, and maybe I want to use Spock for my test framework. Then I can generate the application, and I can either download a zip file, push it to GitHub, or I can use this to get the curl command that I would need to actually create this application from the command line. So the launch application has a full REST API that allows you to create applications that way. So that's the easiest way to get started with Micronaut Kafka. Now I'll jump back to presentation. There we go. And go to the navigator, and we'll swoop down. All right. So you can create the application that way, or you can just add the dependency, which is a simple Gradle or Maven identifier that you can add to add Micronaut Kafka to the application. And then the minimal amount of configuration you need there is at the bottom, and that's just to tell it where your Kafka server is running. So if you were running Kafka with the Docker compose file that I showed earlier, this would work. This would target the correct port, and your application can now produce and consume from Kafka. All right, so now we want to start sending data to Kafka, so that means we need a producer. So Micronaut Kafka provides an @Kafka client annotation, and this is an interface. So notice I don't actually have any implementation here. So again, similar to our HTTP client, I have a method signature that tells Micronaut everything it needs to know to create this producer for me at compilation time. All right, so this producer is pretty trivial. I'm sending a string value, but that could be a full POJO, or it could be an object schema, for example. And that's all I have to do to start putting data into Kafka with Micronaut Kafka. And if I was using the producer API from the Kafka Java client, it's not a ton of code, but it's not bad. So this is a really expressive, clean way to create a producer. And then to use the producer, I just need to inject it somewhere. So I can do that by putting it into my controller constructor. And Micronaut will make sure that producer is provided to the controller when it's instantiated. And now within my HTTP handling here, I can now produce my product to the topic. On the other side, we have a Kafka listener. So this creates our consumer. And same idea, we've got a method signature. And I didn't point this out earlier, but there's this topic annotation that tells Micronaut what topic we want to, in this case, consume from. And now in this case, we can't do an interface because we have to actually do something with the event, right? We have to actually handle it. So in this case, I'm just printing it out. But whatever processing we need to do in response to this event, that could be done in that method body right there. As I said previously, you don't have to just use simplistic primitive values like strings and so forth. You can use a POJO like we're doing here. And the @introspected annotation up there, what that does is it tells Micronaut that you should analyze this POJO, this class, at compilation time and build up all the metadata you need about it. And this allows Micronaut to use even less reflection. It doesn't use very much as it is, but now it can use even less because it's going to build up a metadata map of this class that allows it to know how to serialize it, deserialize it, and it does all of that at compilation time. This is kind of random, but it's a really cool tool, so I thought I'd just throw it in. This is Kafka Magic. Have you used that, Dave? Okay, it's a Kafka visualizer. and it's really easy to set up. So if you got a Kafka cluster running and you're producing and consuming events from it, that's all fine, but it would be nice to sometimes actually look and inspect visually your topics and see the events that are on that. Kafka Magic is just my preferred Kafka visualizer. It's really easy to set up. It runs a server that connects to your Kafka cluster, and then you can browse your topics. You can see the partitions that they're composed of, and you can actually see the results. And so what I'm showing you here is the JSON that's being produced to my topic. That JSON is what came from this POJO right here, right? So I defined a Java object, and Micronaut knows how to serialize this, and it's going to serialize it to JSON by default unless I tell it something else. And that's what the JSON looks like. So notice we have our timestamp up there. We have our topic, our partition number, our offset. It's the very first event on this topic. We've got our key. So there's a binary representation of our key there. And then down there under the message is the actual JSON structure that represents the POJO that we created. So this is a cool tool for visualizing your Kafka data. Kafka events, remember, can have a key, and that's very important because that lets you take advantage of partitioning and so forth. And you can tell Micronaut what parameter you want to use as your key using the @Kafka key annotation. And that works on both the client side. So this would be the producer telling the producer what to use as a key, and also on the consumer side, telling Micronaut again which argument to deserialize and treat as the key. You've already seen the @topic annotation, which tells Micronaut what Kafka topic you want to produce or consume from. That can be also expressed as an array. You can push the same event to multiple topics. That's something that's perfectly valid. And you can use various types of pattern matching and such if you want to send to a combination of topics based on an expression like you see there. The last example there, that's configuration. So if I had a configuration property, custom.topic.name, that would be injected there, and that would be the topic that I would be producing to. Kafka messages can have headers. Micronaut Kafka lets you manipulate, set, and read those headers. You can read them at the method level, in which case just that one particular method is going to include the header, or you can set it at the interface level, in which case so we have a token being set here, token header, and that's going to be set on every method in this Kafka producer. We can also specify consumer groups, and I didn't really talk about consumer groups earlier, but they are important, especially when you have multiple services that are consuming from the same topic. That was something I said earlier on, right? That's a really important benefit of event-driven architecture. It's not just a one-to-one communication method. You could have n number of consumers reading from a topic. And what you want to do in that case is and typically this is going to be each application. Each application is going to have its own consumer group. And what this means is that these applications are able to independently read from a different offset. Okay, so if I have two different services that are connected to the same topic, and one is faster than the other, one of them might conceivably be farther ahead. It might be reading the very latest message, while another service is several offsets behind. Consumer groups are how Kafka takes care of this problem. But it gets even better than that, because I can have multiple instances of this particular application using the same consumer group, and Kafka will make sure that consumers in the same group are not reading in the same messages. This is what makes Kafka so good for a horizontally scalable architecture, because I don't have to worry about, if I have 3 instances of my inventory service, I don't want to be reading the same message 3 times. If they're in the same consumer group, Kafka is able to take care of that problem and make sure that my each consumer group handles the event only once. This brings up something called an offset strategy. And this basically refers to how this consumer group tracking takes place. So consumer group A there in the blue it's currently reading the event at offset 3. Once it's read that event, it's going to commit that offset. It's going to tell the Kafka broker, I got the message at index 3. And Kafka is going to be paying attention to that and making sure that consumer group A receives the event at the next offset. Consumer group B, on the other hand, over there in the yellow, is farther ahead. And that's fine. That's great. So by default, with Micronaut Kafka, this is the behavior. The consumer reads the event, it executes the method, and it commits the offset. And that's generally speaking what you want to do. There are times though where you want to take care of this offset committing manually. And so you can disable the automatic offset commitment. And if you do that, all you have to do is add to our method signature. So this is a consumer, because consumers are, consumers care about the offsets. The producer, they just push it up and they get the next offset. The consumer needs to keep track of where it is, where it's reading. So what we do is we add this acknowledgement argument to our method. And that acknowledgement then gives us sort of the callback that we need to tell Kafka, we got this one. We've committed this, we've finished processing, go ahead and commit this offset. And the example I'm kind of illustrating here is we might receive a message and we don't want to wait for the entire method to complete before we tell Kafka we got it, right? We might be okay letting Kafka say, okay, we're done, commit this offset, bring on the next event to the next consumer that's available, and we'll do our work independently of how we do the offset commit. So I'm showing this mostly to show you that even though Micronaut Kafka is doing a lot of things for you, it's not hiding the power of the API from you. You can do the same sorts of things that you would have done manually with the consumer API. You can still access that functionality. But it's in my opinion, it's a really clean, expressive way of doing that. There's also an annotation at send to, and this will basically, you put this on a consumer so that when it receives an event, it automatically forwards that event on to another topic. And so I never actually had a use case for this, but it's cool. Yeah. Oh, okay. Well, let's talk about that. Yeah. I honestly, to me, this is too much orchestration. Like what I would say is, okay, whoever we're saying order metrics to should be listening to order placed. I'm not sure I agree that this should be done. Oh, okay. Interesting. Yeah, let's talk about that. That sounds fun. Another example, again, moving beyond just the sort of hello world examples that we start off with, is error handling. So a Kafka consumer, in this case, can have an error strategy that basically says, what do you want to do if an exception is thrown and we don't acknowledge the message? We don't acknowledge and commit the offset. So in this example here, we're using the error strategy to retry on error. And I apologize, I really should have taken Ted's advice and used a black on white for these slides instead of dark mode. But we have a retry delay of 50 milliseconds. So we're pacing ourselves, but we're telling the broker we want to retry processing 3 times. And all those, by the way, can be configured. Those could be configuration variables, properties if you wanted. So what's going to happen now is we are going to attempt to handle we're going to attempt to redeliver that message to that consumer up to 3 times with a 50 millisecond delay. There's also, let's see, that's error strategy. Now, if we do have an exception and we don't retry or we reach the end of our retries, we can actually implement this Kafka listener exception handler. And this is kind of boilerplate code. If you're using a good IDE like IntelliJ, Command I, it'll implement this for you. It'll give you the method signature. But the important bit to notice is that it gives you access to this highlighted line here, this consumer record. That consumer record is the raw data that was coming in from Kafka. So it's not been deserialized or anything to any of your object types. And this is kind of where you can decide, if you got a message that you didn't expect for some reason, something was really wrong, and that's why we couldn't process it. At this point, you can kind of inspect and figure out what went wrong. So all that to show you that you do have ways in to kind of handle things under the hood if things don't work out perfectly. And then, wait a minute. I gave this talk last time 2 years ago, and I was being clever here, and I fooled myself. This is actually the code that you would write if you were using the Kafka Java API directly. This is the Micronaut alternative. With the Micronaut alternative, we actually are able to implement a Kafka listener exception handler, and we actually can, with much less code, we can get down to that consumer record. And so the point is that if things go wrong, you can't read in the message. You got to get to the consumer record because that's your data. That's what you're trying to handle. And Micronaut Kafka makes that easier. I tricked myself there with the way I arranged my slides. All right, we're almost done here. Micronaut Kafka does support things like health checks and metrics and tracing. So like most microservice frameworks these days, Micronaut has a set of management endpoints that give you things like, health of the system, disk usage, how many beans are loaded, how many routes are loaded, so forth. What loggers are configured. And when you add Micronaut Kafka to your application, you will get a Kafka health check that will give you information about your connection to the Kafka cluster. So that's very basic health check information. Micronaut Kafka also will feed metrics to the Micronaut metrics endpoint, and that makes use of micrometer, not quite sure how to pronounce that one. And then Micronaut Kafka also supports distributed tracing via OpenTelemetry. And if you know what those frameworks are, you'll appreciate that. If not, they're just really powerful solutions for both of those use cases for gathering metrics as well as distributed tracing. I gave a whole talk on distributed tracing years ago. I should pull it up again because it's a really cool technology. I don't see it used very often. All right, we're wrapping up here. Kafka streams. Let's see. What do I want to say about that? Do I have any more information on that? So Kafka streams. Let's see if I can say a few things on this really simply. Kafka streams essentially lets you apply sort of functional programming constructs, if you will, things like map and reduce to event streams, to your Kafka topic, okay? So if you kind of know how some of that functional programming style works, right? You map over an event and you can kind of transform it into something else, and then you can kind of chain these things together. With Kafka streams, you accept one or more topics that are coming in. You can have multiple topics that are being joined on a common key, for example. And then you define a set of operators or transformers on that data. And then you push the results to an output topic. So, and this is all happening constantly, right? So Kafka streams, if you're using it, you'll deploy this library and it will be running all the time, reading in data, and then applying whatever transformations that you've specified, and then pushing the results to another topic. And this gives you some really powerful capabilities. One of the most common ones is when you do have different bodies of data that live in different topics and they need to be brought together for some reason. So you can do essentially joins. You can combine two topics based on they have the same customer ID or whatever, and then produce a new event that synthesizes elements from both of those events. Micronaut Kafka just gets rid of some of the boilerplate needed to set up Kafka streams, or K streams is the object, the class. And then these K streams can be injected as a bean in your application. So just like if they were a service or if they were an HTTP client, you can inject them through dependency injection, and then you can feed off of the output of those things. And there's also one of the things that Kafka Streams gets used for a lot, and it's not really designed for this. Kafka Streams has this query service that is arguably the simplest way to just query a topic. That's not really its purpose, but it is used that way. If you really need to query data from a topic, there are better ways, either KSQL DB or, like I said, just pipe it out to a database. But there is a query service, and so if you're looking for the simplest possible way to query an event out of turn, just at a particular from a particular event on a topic, the interactive query service from Kafka Streams will do that for you. And Micronaut Kafka makes that easier to get because it creates a bean for you that you can inject to use that query service. And you can see the documentation there. And we're really about done. I just got some resources to share. Micronaut guides. If you go to the Micronaut website and go to our Learn menu, there are at least 2 and maybe more Micronaut guides specifically on using Kafka. So highly recommend you check those out. They're up to date, and the Micronaut guides are really cool because you can choose, like, if you're using Java or Kotlin or Groovy, which are the 3 languages that Micronaut supports natively. You can choose the language and choose the build tool so that all the examples will be in, let's say you use Kotlin and Maven. You choose that guide and you will see all the instructions in the language and build tool that you requested. And then a couple more resources to look at. There is a fairly recent book, Building Microservices with Micronaut, from it says O'Reilly, but I think it's from Pact. Yeah, Pact Pub. And this actually has a chapter on building event-driven microservices with Kafka. So check that out. They got some good information there. There's a podcast which is hosted by my colleague Sergio Delamo. Check that out. And a few other resources. I'll just let you refer to the slides to see these. There's one thing I wanted to show specifically. This is a free ebook, Building Event-Driven Systems by Ben Stopford. It's a little bit, it's a shorter read than the other book that I recommended, which this is a great treatment. This is a quicker read. It's a free PDF if you're willing to give Confluent your contact information. And they will call you, I've learned. Oh, this is what I really want to call out. This is a talk that I just managed to watch recently. Mistakes I've made a few. Blunders in Event-Driven Architecture by Simon Aubrey. It's an amazing talk. And the cool thing about it is that he ends up introducing Kafka and event-driven architecture through the course of the talk. So even if some of the stuff is new to you and it's still kind of not quite gelled, he'll explain, probably better than I did, a lot of the same concepts. But he also goes then into a lot of kind of concrete examples of misapplications, if you will, of event-driven architecture. A lot of it comes down to some of the things that we were talking about earlier about events behaving more as commands and invocations instead of representing data, or not using a database when a database makes more sense. So I highly recommend you check that out. Confluent hosts that talk on their website. The video recording is definitely worth watching. And then little pitch. As I said earlier, this is a very compressed and summarized version of a 12-hour training course, a workshop that I've developed. And if you're interested in that, there's a place where you can request more information there on that website. So do check that out. I love talking about this stuff, and we can talk about it now. I think we have some time, right? We're good? Okay. So that's all I had. Thank you. And there's just a request to repeat questions from the local audience, which I will do. All right. Yes, sir. Yeah. So if by fail you mean it through an exception, excuse me, we saw that one example I showed earlier where you can specify an error strategy, right? So you can retry the event some configurable number of times. That's one option. There's a few different methods that you can take, and actually this does play into the talk that I mentioned earlier by Simon Aubrey. The typical way folks handle that is through something called a dead letter queue, which basically is a end of the road topic that you send the failed event to so that it can be triaged and dealt with manually. That's one way to deal with it. The other way, and this is what Simon recommends in his talk, is just have some means of freezing the process in place at that point. Just don't do anything. Don't send the next event and let that thing stall out, and then figure out what needs to happen and then pick up from there. The issue with dead letter queues, in his telling, I think I can relate to this, is that it sometimes makes it ends up not helping you very much because you really can't start from that event that's been messed up and keep going. You end up having to restart the process anyways. So it really depends on what it is you mean by failure, right? Because if the failure was that the event was corrupt, you're not going to recover from that. You're going to have to go back to where that happened and kind of start over. Whereas if it's because a third-party vendor or some other service was down and you couldn't do your job, well, that could potentially be recovered later on, once the dependency is available again. So it's very use case specific, I think. But those are the basic mechanisms. You can have exception handling, which can get you over maybe just a very temporary outage or glitch. Then you have dead letter queues, which are more permanent until you come back and do something with them. Or if you can design your system in such a way so that you can just stop at that point in your flow and address the issue and then go on from there, produce the correct event, and then trigger the rest of the process.
As a reminder, can you please repeat the question for
Oh,
the record audience?
I just said I would do that and then I forgot. Yeah, so the question, and hopefully you could tell by the context there, was around error handling. And just how do you recover from a failed processing of a message? So which we mentioned that briefly earlier in the talk, but we just were addressing that a little more. Does that help at all? Maybe give me an example, like what kind of use case do you have in mind? Because that might help me be more specific. Okay. Okay. Yeah. Yeah. So he was describing a previous project where there was a dedicated retry service that existed simply for this problem, right? Of basically, publishing the correct event, right, and kind of re-triggering the processing after that failure point, right? So, I mean, that seems like potentially a very reasonable way of going about it. It's just going to depend a lot on, what do you mean by a failure? Is it something that you really could play this exact same event back and get a successful run, or is that never going to happen? If it's never going to happen, then you've got to back up and get to a point where you can produce the correct message, and that's kind of what you were describing. But if it's simply that we couldn't process the message, then you might just need to find some way of either holding up the process or using a dead letter queue or something where you can wait out the problem or resolve the problem and then pick up processing from there. You got any thoughts there, Dave?
We've had some situations in our system where like messages will take too long to process, right? And so the polling will time out and they're not offset to be submitted on time. And by default, it'll go back into the queue to be processed. What happened with us is that it'll just keep happening. We'll be stuck in this loop because the default handler is like, yeah, just keep retrying. And so you just end up with this batch of, maybe 10 or 15 messages. It's spun up. Your service is doing nothing. And it's not really going to the back of the line. It's being tried as soon as possible. And so nothing is being processed. Everything is just backed up. It's just retrying this message that can't be processed. And so we had to move to a dead letter handling. And say, all right, had to configure our retry strategy on failure retry. Just go to the next message. And then with the assumption that our handler would send it to a dead letter. Broke us out. By default, it will not do that. So you have to configure that.
Yeah, just to summarize that for folks online, essentially, if a dead letter queue doesn't do a lot for you, right? It's a holding pattern, and then you have to build what you actually want to do. That's going to be functionality you're going to have to build.
It is dependent on the time to failure. So a lot of times we would have failures in the middle of like an onboarding process, where like maybe the service would be down, something that we needed to happen wasn't able to happen, and so the dead letter queue takes place. So now we can go back manually and just throw it back on there when we know the service is up, and then the rest of onboarding happens. But not every failure is able to be done like that. And again, getting processed. So yeah, it is kind of dependent on your failure case.
Yeah. Yeah, but in the sense, it's not really any different than any other type of processing failure, right? It's the fact that it's on an event stream does add certain considerations, but it's going to be very specific to the type of processing you do and what that failure means. Maybe it's not a big deal. Maybe it's like we just couldn't get this particular the analytics client didn't get this one, and is that really a deal breaker? Maybe it's not. Maybe we just try again next time, and it's not something that needs to be dedicated, have dedicated functionality. I do have a question coming into the chat here. Does the Micronaut Kafka client have affinity to the broker in a cluster? In other words, does it default connect to the nearest node? So I think what you're referring to there is the connection there between the client and the broker. Is there some sort of like if you have a geographically distributed cluster and you've got multiple regions or whatever, it doesn't really work that way. And this is not Micronaut specific either. The consumer and producer are just going to go with the Kafka Bootstrap server that you provided. So if you have, there is, you can certainly set up a Kafka cluster to be multi-region, but that's not really a broker or consumer level concern. I don't want to say too much here because I could be mistaken, but when it comes to your initial question, does the client have an affinity to the broker? It doesn't really work that way. The broker is basically listening for consumers that register themselves, and as part of a consumer group, and then it's kind of load balancing the messages, the events that get sent to those consumers. And so it doesn't really, there's not like a particular broker as a particular connection. That's not something that really is a factor in my experience. You have multiple brokers, so you can have some horizontal scalability, and brokers, actually I have more information, slides on this topic in my longer deck. But there is some cool stuff going on in how brokers kind of self-manage. They do leadership elections. They kind of have one broker that's always accepting the consumer, the consumers are being registered, and then it has means of handling situations where a broker goes down. So it's a really interesting topic, but yeah, if you're a consumer, you don't really care. You're going to take the events that get pushed to you. Any other questions in the room?
Yeah, I had a quick question.
Oh.
What happens to if an event is sent and then it's voided? Do both the original event and the voided event get taken out of the stream, or do they both get left in the stream and the processors have to handle it? Thank you. Great presentation too.
Thank you. Good question. So the short answer is no, you can't void an event. So the events are immutable. So once they've been published to a topic, you can't get rid of them. Now there is such a thing. You can, if you have an event that has a particular key, and let's say you've got a stream of events that represents a customer profile, which this brings up an interesting issue actually when it comes to like what was the name? It's got in my mind. What's the EU thing about not holding on to GDPR? GDPR. Thank you. When you have a customer profile event, right, and that customer goes away, you don't want to have their data showing up in your queries or whatever. What you can do is you can publish an event with that same key and no data, right? So that if you were to query that data and you get the latest event for that key, it's gone, right? You effectively erased that profile, but it is there, right? It's still the previous versions of that profile, the previous events are still there on the topic. So there's not really a clean way of just purging the events that have been persisted. So if you have data that you need to be able to get rid of cleanly, you're not going to want to put that on a topic that has, indefinite persistence. There might be an approach to doing that, right? There's
like kind of two types of topics with like cleanup strategies.
That's right.
There's ones that have like the loop where it's like give it a persistence level, and then once they go away, they actually drop out. But then there's that
compacted topic. That's right.
So whenever you send one of they call tombstone messages, right? It will compact the history of that message to nothing, and so
Yep.
it will kind of be erased from compacted topics.
So a compacted topic, thanks, Dave. That escaped my mind for a minute. But yeah, a compacted topic essentially only holds on to the latest event of a given key. So if this imaginary customer profile is on a compacted topic and you publish an empty profile with the same key, then that's going to be the only event left on that topic. So that does give you a way of essentially voiding or erasing data. But to answer Ted's question, that doesn't really affect the handling of the event. The event's going to still be sent out to any available consumers. We've got another question in the chat. Can the Micronaut client use exactly once Kafka message semantics? I'm trying to recall exactly once. So the answer is yes, in that the Micronaut Kafka client will work with any. It relies on the same Kafka guarantees that the straight Kafka Java library does. So yeah, if you can do it with the Kafka Java library, then yes. I'm trying to recall exactly once if that's specifically something that the Kafka guarantees cover, though. Yeah, if you can do it in Kafka, you can do it in Micronaut Kafka. Yes. Oh, very good. So the question is, are there any resources for teams that might want to look at moving from a more messaging-based paradigm to a more event-driven model? That's a great question. The only resource that I know that really addresses both and kind of gives you some of the distinctions would be actually try to bring up my navigator here. So building event-driven services does cover the differences. But as far as like moving from one to the other, I'm not sure I know of a particular resource that talks about that in depth. I'm thinking of there's a couple of architecture books I like, but and they talk about event driven, but they don't really talk about the migration strategy. I think that if you're already doing messaging, it's going to probably be an easier shift than if you were going from a more traditional orchestrated solution than trying to move to event driven. If you're already doing messaging, you've already got part of the solution in place. What you basically need to do then is decide, okay, of these message queues that we're using currently, you're sort of doing kind of you're almost doing event modeling backwards, because what you're trying to do is kind of say, okay, if I were to make these messages, stateful, they were actually persisting state, right? You're going to sort of figure out, where the and it helps. It's really helpful, I think, to think in terms of the topics, because the topics represent essentially the topic is the message type, right? So you're saying, okay, I'm going to replace where currently maybe I'm just emitting events to a RabbitMQ queue or something like that. We're going to stop doing that now. We're going to start, or maybe we'll keep doing that, but we're also going to publish this out to a topic. And now maybe if I'm refactoring another service that has been receiving message on this queue, and now I've got a topic available with the same data, well, I can use a consumer instead, right? Or maybe I don't want to change my existing services, and that's when I add a new service. So the cool thing with Kafka and with event streaming is that it works really well even alongside other ways of solving the same problems. It's not like a either or. I've got to go all in on Kafka, do everything on Kafka. You can ease into it, and you just got to be okay with the data being duplicated. And it's okay because it's immutable. It's not like you've got to get them back in alignment. Whenever a new message happens, a new event goes on to the Kafka topic, and they should be. It's then sort of a matter of, as a particular part of your architecture becomes flexible because you're refactoring or because you're adding new services, those things start to move more towards treating the events as data and not just as notifications. But they're both. So it's not like you're forced to choose between one or the other. Oh, sure. Okay. Like between services? Okay. Mm-hmm. Okay. Yeah, I see what you're saying. I see. So the thinking is, okay, so if you have an existing microservice type architecture or distributor architecture, and you're doing a lot of inter-service communication over HTTP or TCP, how do you move from that into event-driven? And yeah, certainly you could use events as your inter-service communication, right? And that they do that, right? That might not be it might not be academic event-driven architecture, but it would be an improvement, likely. You would not be as reliant on network connectivity and issues like that between your services. And then I think what you would want to do is start to see, okay, where does this allow, because what you really want to do is move from, again, this sort of orchestration to more choreography, right? So move from my services are telling each other what to do to my services are saying what happened. And other services are saying, hey, I care about that. I'm going to do something because this happened. And that's really where you shift from being just kind of messaging as in notification to being event driven. Event driven is I'm telling the world what I've already done, as opposed to telling you what I want you to go do, which is, that's more brittle, right? Because I have to know you exist. And if you change, I've got to know about that, right? Whereas if I'm just saying what I'm doing, then if you decide to change how you handle something, well, that's kind of your business. It doesn't really necessarily affect me. Now, that's the ideal, right? It's fully possible, and I know this because I've done it, to build brittle or not just brittle, but tightly coupled services in event driven. So you still need to be kind of mindful of what it is I'm actually pushing out to a topic. Am I pushing data or am I pushing intention? So I'm pushing intention. Well, now I care about who's listening. If I'm pushing data, I don't really care about who's listening. So that's kind of the way I would think about it. So you can certainly replace the inter-service communication with events, still mostly following the same topology, the same model you already have. But then as the system evolves, start thinking about, okay, where can I make this less imperative? Where can I make this less concerned over who's saying what and who's it talking to, and more concerned about what data do I need and what data do I produce? Sure. Like actually pushing requests to a topic? Interesting. Mm-hmm. Yeah. Yeah, I'd be interested to know, I guess. Yeah, let's talk offline. All right. Any other questions? I know we're a little over time now. I don't see anything else in the chat. Hey, Bruce, I think we're good. And I will send the updated slide deck to Bruce because the one I sent you is missing some of this. So, but they will have it up there eventually. Do you want the raffle? That's why everyone's here. I was like, I thought they were all enraptured with my oratory skills. That's right. I'm going to answer a question online. What other options does Micronaut have other than Kafka for EDA? If you look on the Micronaut launch website and you go to your messaging app, there's a few different messaging options. So there's Kafka, there's RabbitMQ. I believe there's Pulsar support. Kafka is the dominant event-driven solution, though. So the others are more along the lines of message queues than event-driven.